Continuing on in note 6.6, we are going to do a similar analysis to define inverse cosine and inverse tangent. So first we're going to look at the graph of cosine x. That's at the top of the page. So this is the graph of f of x equals cosine x. Remember, cosine x passes through the point 0, 1, and then it has a key point every quarter period. The units on the y-axis are 1 tick mark is 1 unit. So the domain of cosine is all real numbers, so negative infinity to infinity. And the range is all possible outputs, which range from -1 to +1 inclusive. So that's our range. Now we're going to look at cosine and we're going to say, is this function 1 to 1? To be 1 to 1, the graph has to pass the horizontal line test. So no, f of x equals cosine x is not 1 to 1 because it fails the horizontal line test. So each output has more than one input. Okay, so this is not 1 to 1. So since it's not 1 to 1, the inverse will not be a function, right? Its inverse will not be a function. So carrying on, just like we did with sine inverse of x, we want to restrict this function, the domain of the function, so that its inverse will be a function. Oh, and I guess I'll go back a second. If I draw a horizontal line on the graph of cosine x, you can clearly see that it does fail the horizontal line test. Okay, so continuing on. How can we restrict the domain of cosine x? So we wanted to restrict the domain of cosine x here. So it is 1 to 1 and still takes on its full range of values. Like sine of x, there is more than one interval that we could choose, but the interval that's chosen is the interval from 0 to pi. So we are going to take the piece I just highlighted. We can see it takes on all values in the range from -1 to +1. And now this function is 1 to 1. Right? So its inverse will be a function. So the restricted domain is going to be from 0 to pi. The range is still -1 to 1. That was our goal, was to keep these ranges the same, but restrict the domain so it will be 1 to 1. Now we're ready to define the inverse cosine. So the inverse cosine function is defined as y equals arc cosine x or y equals cosine inverse x. Those are equivalent notations. I expect you to be comfortable with both. If and only if cosine y equals x, and the inputs are going to be -1 to 1. Those are the range of the original functions. The outputs, y goes from 0 to pi, is the same as the restricted domain. Remember, inverse functions switch inputs and outputs, domains and ranges. Helpful phrase, whenever I'm evaluating an inverse trig function, we can think of the arc cosine of x or cosine inverse of x is the angle in radians whose cosine is x. And we're going to do that more in upcoming examples. A hopeful thing to remember is on the unit circle, the output values are going to be between 0 and pi. So outputs of y equals cosine inverse x are on the top half of the unit circle. So from 0 to pi inclusive. And that's going to be really helpful when we evaluate inverse cosine. We're going to do the same analysis quickly for tangent. Oh, but first, let's take a look at the graph. I'm just showing you here. This is the graph of cosine inverse of x. And it is the reflection of that little piece of the cosine function that we highlighted up here. Now let's go ahead and do the analysis for inverse tangent. we'll do it a little more quickly. So we can say we can restrict the domain of f of x equals tangent of x by taking one cycle, and the cycle that is chosen is this kind of base cycle between negative pi over 2 and pi over 2. Clearly, we can see that this function is not one-to-one, so we need to restrict it. The restricted domain is going to be the open interval from negative pi over 2 to pi over 2. The endpoints are not included, right? Those are where the vertical asymptotes occur in the parent function. So it's going to be the open interval from negative pi over 2 to pi over 2. The range is all real numbers, right? Because we're going from negative infinity to positive infinity. Definition of inverse tangent, similar to the other two we just defined. It's defined as y equals arctan x or tangent inverse x if and only if tangent y equals x. And we can have any input for tangent inverse. That's the range that we had before. But the outputs are going to be defined in the interval from negative pi over 2 to pi over 2, which was our restricted domain for the tangent function. Helpful phrase, the arctangent or tangent inverse of x is the angle in radians whose tangent is x. It's one singular value. And tangent inverse x, I'm going to draw this just like I did for the other ones. This is where the outputs are. So outputs for tangent inverse of x are angles in the interval from negative pi over 2 to positive pi over 2, where the endpoints are not included. And at the bottom of the page, I've sketched what tangent inverse of x looks like, just so you can see it.